Okay, so in number one, I've asked you to write the function y equals negative x squared minus 4x minus 1 in vertex form. We do that by completing the square. Just a reminder, all three of these problems are problems that came from your assignment. So if you did your assignment, they'll look familiar. If you didn't do the assignment, maybe jot these three problems down and you at least have it started. I know number one, I think question number one here was number 19 from the assignment. Yep, number 19 on the assignment. So we have to complete the square. When you complete the square, you kind of disregard the c value initially, that -1. So I'm going to kind of break it apart from the rest of that problem. Look at the first two terms, and we should identify that, hey, there was an a value. We don't want an a value when we complete the square, so we have to first factor that out. What is that a value? What is the coefficient? -1. So I have to factor that out. But only from the first two terms. I don't really care about that last one yet. So when I pull -1 out of the x away from negative x squared, I'm left with x squared. I'm really factoring out as like undistributing it. Then I had -4x, but I divide out -1. That leaves me with positive 4x. I divided by -1. Okay, so that's what I get when I factor out of those first two terms. I still have the -1 at the end of the problem. So I've just factored out -1 from the first two terms. And now comes the completing the square portion. I have to figure out what number do I want to put in that blank in the C position. And so remember how you complete the square. You take the b value, you cut it in half, and then you square it. Our b value is 4. Half of 4 is 2, and 2 squared is 4. So I'm putting a 4 in here. Now, we can't just go and modify one side of the equation without considering the implications, right? We're not trying to make it worth a different value, otherwise it's not true. So I have to adjust for that. So remember also, there is a -1 in front of that parenthesis. I actually didn't just add 4. I added 4 inside of the parentheses, but when you consider that there's a -1 outside that would be distributed into it, I actually brought in a -4. So if you do a -4 to the left side of the equation, you can subtract 4, from the right side of the equation. We could subtract 4 from the left side of the equation if we want to put it over with the y, or the alternative, if I want to stay on the right side of the equation. Think about the fact that I just subtracted 4 from the right side, so then I could also add 4 to the right side. That way they would cancel each other out. So I've completed the square. Now I'm ready. Whoa, I didn't mean to lose that from the screen. There we go. Now I want to factor the parentheses down. It should become a perfect square. I don't really have to put the 1 there in front of the parentheses. I can just leave it as a negative. It becomes x plus 2 squared. And then the -1 plus 4 becomes plus 3. And that's all I asked for in this problem. It's just right in the vertex form. I didn't ask what the vertex was. I just asked for it to be in vertex form. We're finished with that one. Then we move on to number 2. So in number 2, we have something that's already in vertex form, and I'm asking you to graph it. It would be helpful to know what the vertex is. So I would start this one by finding the vertex. Well, your vertex, the x part of it, you look in the parentheses. The parentheses say x minus 5, but we have to do the opposite of that. So instead of -5, we use +5. And then we look at the number after the parentheses. In this case, it's a +5, and that is that what I wrote originally, was +5 there? That wasn't the problem I meant to do. On your assignment, it was actually a -2 there. I don't know why I have a +5. So if I were actually stealing the problem from the assignment like I meant to do, I just copied it down wrong. Should have said -2. I'll keep going with this since I already have it written down, but know that it's slightly different. This was supposed to be number 26 from the assignment, but I messed it up. But we'll continue with it. So your y value would be the +5 because we want it to match the k. So 5, 5 is our vertex. And so if we make a table of values, I would put that in the middle, the value, and then I would want to surround my vertex. So pick x values that surround 5. Maybe we would go with 4 and 6. And then plug them in. So let's plug in 4. So y will equal -3 times 4 minus 5 squared plus a 5. Make sure you follow your order of operations. 4 minus 5 is -1. So -1 is squared. Square before you multiply, so square the -1, giving you +1. So we have -3 times 1, which is -3, plus 5. -3 plus 5 gives us 2. So I get a 2 when I plug in 4, which means I should get 2 when I plug in 6 also. I'm confident that I haven't made any mistakes, so I'm going to go ahead and go with that. So let's graph now. So 4, 2, 5, 5, and 6, 2. So we've got our points, and now I'm ready to connect the dots. Looks very similar to the parabola we have in number 3. Very similar, but not quite the same. It's like it's shifted up 1 from what we did in number 3. So number 3, we work backwards. We know the parabola, and we're supposed to identify what the equation is. We're supposed to put it in vertex form. So I would start with your general equation for vertex form. I'm going to get rid of my background, the dots, for just a little bit. I'll probably come back to them later. What is the h? What is the k? Well, that's the vertex. The vertex is h and k, so you can plug those two numbers in. So y equals a times x minus 5 squared plus your k, which is 4. So your vertex gets plugged in. We need to identify what a is, and I did not give you a. What I did give you, though, is another order pair. It's not a significant one. It's not the vertex. It's just an x and a y. So plug those numbers in for x and y, and only temporarily until I figure out what a is. But plug 6 in for x and 1 for y. So notice everything now has been plugged in for except for the a, which means I will be able to identify what a is. 6 minus 5 is 1, and when we square that, we get 1. Do not add 1 and 4. The 1 is connected. It's multiplied to the a. Subtract the 4 away to get a. So we now know that a is -3. So now I can give my final equation. Y equals -3 parentheses x minus 5, close the parentheses and square them, plus 4. So I plugged in the a, the h, and the k. So That was from the assignment. That was question number 38 on the assignment. I meant to have 3 problems from the assignment. Number 2, I miscopied it, so it wasn't actually on there. Oops. Cut it in half and square it. Take the B, cut it in half, square. Okay, so that was 4-7. That's what we covered on Tuesday after the quiz. Now, today we need to take a look at section 4-8. New note, section 4-8 is titled Quadratic Inequalities. This is the final section of the chapter, which means once you complete this section, you'll be ready for the test, I hope. The test is the block day of next week. So in this class, that's Tuesday. Tuesday we'll take the test over all of chapter 4. Tomorrow. All right. Two types of problems we're going to talk about. First is just graphing an inequality. And this one's nothing new. It's just taking the idea of inequalities and quadratics and putting them together. We've done both of those things, so that shouldn't be a big stretch. So we're going to graph y is less than or equal to x squared plus 2x plus 4. So you look at this equation, you should notice it's in standard form. And so we're going to pretend for a little bit that it's just an equal sign and go through the whole process that we would have gone through earlier in the chapter. And then at the very end, we'll come back to the fact that it's an inequality, which means we have to consider whether it's a solid or a dashed line and where to shade. But because it's in standard form, let's first find our vertex by using, or the axis of symmetry actually. Let's start with the axis of symmetry. So we use our equation x equals, and we do the negative b over 2a, remember that one? So our a is 1, our b is 2, our c is 4, so plug those in. So negative b, so that's a negative 2 over 2 times 1. So we end up with negative 2 over 2, which is negative 1. And we know our vertex is on that axis, so its x coordinate has to be the number I just found, the negative 1. So let's find the y value that goes with it. So you plug negative 1 into the equation and solve. We're plugging negative 1 in for the x, so it's negative 1 squared plus 2 times negative 1 plus a 4. 1 minus 2 plus 4 is 3. And we would like additional points. When we first learned graphing, I said we need to have 5, but on both of the quizzes, I've said you only need 3. So let's go with the 3. I'm okay with that, as long as you understand what a parabola looks like. We put the vertex right in the middle, and we just want to surround it. So if I go 1 bigger than negative 1, I would have a 0. 1 less would be negative 2. I'm glad we're using a 0. It's easy to plug in 0. You plug in 0, the x squared goes away, the bx becomes a 0, you're left with just the c, which was 4. And that means negative 2 should give us the same answer, unless we made a mistake. Let me put a background on here so I can graph that a little better. So negative 2, 4, negative 1, 3, 0, 4. I'm okay with the 3 points as long as you can make it look like a parabola. It's not going straight up and down, but its slope becomes steeper as you go. It's not a V shape. Oh, now hold on a second. I forgot the fact that this is an inequality. And I was supposed to decide, is this supposed to be a dashed line or a solid line? Should this, I got lucky, this one was supposed to be solid. I know it because it's a less than or equal to means it's a solid line. So I got lucky, but I do need to shade. I have to figure out where to shade. I'm either shading everything that's inside of the parabola or everything that's outside of the parabola. So we can test a point that's not on it, like 0, 0. Let's test 0, 0 and see if it works. We plug 0 in for the y, 0 in for the x. So I get 0 is less than or equal to 4. Is that a true statement? Yes, it is. So 0, 0 should be shaded. It's outside of the parabola, so therefore everything outside of the parabola should be shaded. So that's how we would graph a quadratic inequality. That's not a big stretch from anything we've done previously. But the second type of problem, we go a little bit beyond that. So now we'll probably do a couple of these, but we are going to solve the inequality. Not graph an inequality, but solve an inequality. And there are a couple of ways to do that. But let me give you one of them we're going to solve. 0 is greater than x squared plus 5x minus 6. Notice, when we have an inequality that we're solving, there is only one variable, not two variables. When we graph something that was one variable, we end up with a number line. When we graph two variables, that's when we have the x-axis and the y-axis. This only has the x-axis. Now it is related to the parabola, but it's really just a cross-section of the parabola because we only want the x-axis portion of it. Let's think for a moment about what this parabola might look like. I'm going to get rid of my background again because I'm just going to sketch. I don't even care about exact values. What I do care about is this: does this parabola open upwards or downwards? Upwards. The a value, the number in front of x squared, is positive. So we know we would have a parabola. Now this one would be a dashed parabola, wouldn't it? But I don't know exactly where that is, but most likely the x-axis is going to intersect it somewhere. And if I'm looking at the cross section, I want to know what's happening on the x-axis. I don't care above or below, but I would care about those two values and whether we're shading inside of that or outside of that. That's what I have to consider. But I need to identify what those values are. We call those x-intercepts or zeros. You can graph this on your calculator and find your zeros, or you can solve it algebraically by using factoring, quadratic formula, completing the square, any of the methods we've used. This one appears to be factorable. No, it is factorable. What would the zeros be? -6 and +1, which tells me, if I go back to my graph, my y-axis goes somewhere like that. And I know what the x-intercepts are. 1 and -6. The question becomes, where are we shading? Are we shading inside of there, or are we shading outside of there? Well, I could test the number. I could test the value. I only have to test an x value this time. I can't use the -6 or the 1. So really, I've got a number line here, right? Open circles. Open circles because it's not an equation. It's not equal to. I need to identify whether shade inside or outside. Can I pick a number like 0? 0 is between those two. If 0 works, then I would shade in between them. If 0 doesn't work, I would shade outside of them. So let's test 0. It is a number line. Plug 0 in. I get 0 is greater than -6, and 0 is greater than -6. So 0 should be shaded, so I should therefore shade everything between those. Which tells me, had I graphed the parabola, if I'd graphed the whole parabola, my solutions were inside of the U, since my shading was inside. So now to express my answer, since it's in between, that's an and. Remember our ands and ors? -6, not equal to, so as -6 is less than, x is less than 1. Because our solutions are between the -6 and the 1. Question?
So could you use like the same method for the second one?
So the graphing?
Yeah.
So the question was, could I have graphed this to identify? Absolutely. But when you make your table of values, remember over here when you make your table of values, if your y values are not zeros, they're not the actual points we care about. They're helpful in getting our graph, but we would ultimately need to know where your x-intercepts are. On this particular graph over here, actually everything was shaded, and there were no x-intercepts. There, the answer would be all real solutions. But we would need to identify our x values or our x-intercepts or our zeros. So using a graphing calculator or Desmos might be helpful to do that. But yes, we can use a graph to do that. But you do have to identify whether the shading is between the points or outside of them. So these are two different types of questions. The first question just told you to graph and it had a y in there. This one is solve and there's no y, there's a 0. So ultimately you have to find the x-intercepts. You can find those by graphing, by factoring, by quadratic formula, completing the square, whatever you need to do to get those values, and then figure out whether the shading is inside or outside of those. Let's do one last example. -x² plus 3x plus 10 is less than or equal to 0. I want to solve this. I want to find the x-intercepts of the zeros. You can graph it. This isn't factorable. It's not a great completing the square problem. Maybe I'll use quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, a lot of people kind of like the quadratic formula, but a lot of people aren't good at it. And that was true that was apparent on the quiz. A lot of people made mistakes on quadratic formula problems. -3 plus or minus the square root. We get 9. -4 times -1 times +10 is +40. All over -2. -3 plus or minus the square root of 49. All over -2. -3 plus or minus 7. All over -2. Consider both answers. -3 plus -7 all over -2, and -3 minus 7. I don't know why I said plus a negative. Sorry. This one I meant to, let me go back here. I meant to say plus 7 all over negative 2, and I meant to then say negative 3 minus 7 all over negative 2. Negative 3 plus 7 is 4. 4 divided by negative 2 is negative 2. Negative 3 minus 7 is negative 10. Negative 10 divided by negative 2, positive 5. This tells me that that was indeed factorable. We could have chosen to solve it by factoring, but we could have also solved it by graphing. But those are the x-intercepts. Those aren't the answers to the problem because it doesn't say negative x squared plus 3x plus 10 equals 0. It says less than or equal to, so there's more answers than just that. Think about the number line. Negative 2 is the smaller one. It's further to the left. 5 is the larger one. It's further to the right. Are those numbers actually solutions? Yes, it should be closed intervals because it was less than or equal to. That's where it was equal to. I need to identify, should I be graphing the numbers in between those or outside of those? So we can test the number. Test 0, and 0 is between them, right? Okay, 0 would be somewhere around there. Test 0 and see if it works. I get 0 plus a 0 plus a 10 is less than or equal to 0. Is 10 less than or equal to 0? No. 0 should not be graphed. I should not be graphing between them. So instead, the solutions are outside of there. So to the right of the 5 and to the left of the negative 2. So remember how we write that. X was less than or equal to negative 2, or X was greater than or equal to 5. Had I graphed the parabola, it was upside down, would have found those x-intercepts, and the shading was clearly outside of the parabola, since that's where our shading was. You can use the graph to help you identify. It would have been a solid line. I did it as a dashed line, not because it would have been dashed, just because I don't know what the actual parabola was, but it would have been something like that. That would have been better. All right, so that's 4A. That's the end of the notes. There is an assignment on Canvas.